engine. So the Spark itself does not use the MapReduce as an execution engine. However, it can integrate with Hadoop if the Hadoop is installed, and it can be run via Yarn and use the Hadoop file formats and the HDFS storage. If we want to, we can run it in the standalone mode. So it has its own engine that it runs. So it is best known for its ability to persist large data sets in memory between the jobs. It is built on what is called a resilient distributed data set, or RDD, which is its own data structure that it has. And so it's a distributed collection of these data structures, and anything that we create in Spark is stored in one of those RDDs. So this is like a partition part of the disk that is designated for processing by Spark, and it can contain code or it can contain data. So it's just a distributed collection of objects. Each of these RDDs can be split into multiple partitions, and they can be each one computed on a different node of the cluster. So the RDD can contain objects of any type. It could be Java, Scala, Python objects, and including user-defined classes. So the users can create these RDDs They can create them by loading a text file as an RDD using Spark context text file, which is this. So they can load this text file into an RDD, and they are going to statically create one of those. Or the users can create it by distributing a collection of objects. So a list or set in their driver program. And once these RDDs are created, they offer two types of information. They offer two types of operations: either transformation or an action. So transformation is when we are transforming the current RDD. So we're making some changes to the current RDD and setting it as a new one. And the action is when we want to do some take some action with the data. Let's say we want to search through the data for a particular word. Let's say, give me all lines that contain the word error in this text file. And that's what it's going to do. So that's an operation that we can do on this RDD. So either they can return it to the driver program if it was created by a driver, or it will save it into an output file as it saves it here if it is statically created. So the key idea is that these resilient distributed datasets, RDDs, are collection of objects across the cluster with user-controlled partitioning and storage, so the user can say how many partitions this RDD will have when it creates it, and they are automatically rebuilt if there is a failure by the Spark engine. And we can perform parallel operations on these RDDs. So we can do transformation, such as map or a filter of the RDD, or we can take some actions such as querying the data or searching through data and so on. As we mentioned, it supports all these programming languages: Python, Java, Scala, and R. And Scala is the language on which Spark is written. And Scala stands for scalability, so a language that allows us scalability. It is based on Java, and it is though much shorter. So, and the syntax is much more concise and easy to use for Spark and for this distributed data processing. So as you can see, the same thing in Scala is 2 lines, and in Java is like 6 lines. So filter the RDD and return the lines which contain the word error and count them. And if we have to do in Java, then we have to say lines.filter, create new function, the parameters, string and boolean, and then call it, passing the parameter, and return the lines if they contain error, and then count. We mentioned that if the RDDs are lost, they will be automatically restored by the Spark engine. So they will track lineage information in order to rebuild the lost data. So we mentioned that each RDD has a partition, so we track can have a number of partitions, so we track each partition for these recovery purposes. Let's see an example from machine learning, just to show the difference if we do that in Spark and if with the Spark computing engine versus the Hadoop and MapReduce. So logistic regression, this is when we are mapping points into a regression line. So we want to map parse point, and we're caching that. So variable vector zeros, and then for I, from 1 to a number of iterations, then we're going to have gradient equal to points.map. And so it is mapping points to the gradient line, as you know in regression. And this, if we see this done in Hadoop MapReduce, it has a number of iterations. So this is one of the methods that I mentioned that requires many iterations, so it will not be very efficient in MapReduce. And so if we do it in Hadoop MapReduce, it takes 110 seconds per iteration with that particular data set of points that we gave it. As an input with Spark, first iteration will take 80 seconds, and any of the following iterations 1 second. So you can see here, the blue bars is for MapReduce, and the red ones is for Spark. This was done with 100 gigabytes of data on 50 machines. So you can see with iterative computations, the Spark engine is much better than MapReduce. Other things you'll see here, and the reason it does that is because it's able to hold large amounts of data in memory. And so if we have less memory, what happens? Percent of working sets in memory. Iterations. Okay, so if we have about 68 iterations, then it is not taking, let's see here. The less number of iterations we have, it takes less memory, which is obvious. So it is storing the data in much more data in memory while it is processing it, compared to MapReduce, which is keeping it on the disk, and every time it has to go and access it, it's very slow. So the